Hello again. So you're back to talk a little bit about the enantiomers and diastereomers. In the previous uh, presentation, I talked about the enantiomers. If you recall in what I call it 5, A5 3D-2 or point 2, we talked about these two molecules and we said they're really mirror image of each other. So if you look at this iodide, the same as mirror image of it here. Remember, to see them, we put the red one as hydrogen. Even typically, hydrogen is white. So we have two hydrogen here away from us, and we call this bromine. So bromine is coming toward us, and the same for the mirror image. And we talk about how to go from a three-dimensional structure to a paper, because really we don't have models all the time, so we really need to uh, do something with the paper. So on paper, we talk about iodide, carbon, carbon, and chlorine. We pretend they're on the paper. So here's iodide, carbon, carbon, Cl. Away from us are the two hydrogen. Coming toward us are two bromine. Now, if you go back and look at the priority, remember iodide has higher priority. So this would be number 1. This is number 2. And the carbon-carbon bond has number 3. So again, it says S. Same thing here. So we have two S's. Now, if you look at the mirror image, again, iodide has the highest priority, then is Br. H for both cases are 4. Priority 4, we can ignore it. And that's what I did. So I put the H away from us to make it a little bit easier to see. So again, we have priority 1, priority 2, priority 3. So this is the opposite to this. This is a R. And the same thing for this carbon. Carbon number 1 is R. Now, why did we call this carbon number 1? Oh, it's hard to see it. And carbon number 1 here, because from the naming, not to do with stereochemistry. If you remember, we naming this compound, we have to differentiate between bromines are the same, so we have to differentiate between the Cl and iodide. Letter C comes before letter I, so this carbon gets carbon number 1. Same thing here. This becomes carbon number 2. Very simple. Just naming, loose naming. Nothing to do with the stereochemistry. So now what I'm going to do, so these are called, if you recall, because they're mirror image of each other, we call them enantiomers. Enantiomers have the same thing, same property, same melting point. Everything's the same except optical activity. We're going to next presentation. We'll talk about optical activity. So optical activity is a little bit different, but everything else is the same. There are going to show you some sample that the smell is different for enantiomers. But physical property besides the optical activity is the same. So I'm going to pause and then going to change that. So I like to change maybe I'll change the two of these bonds to get with each other. Maybe I put bromine here and chlorine there and see what happens to the two molecules. Okay, I'm back. So what I did, basically I left this one alone. So nothing changed there. So we still have the two bromine. Remember I made them a little bit blue. Coming toward us, the two hydrogen away from us. Now iodide, or iodo, carbon, carbon, and chlorine still on the plane, on the paper. So again, if you go and draw it on the paper, we show the iodide, carbon, carbon, and Cl on the paper. Bromine or bromo is still coming toward us, and the red hydrogen going away from us for both carbons. And it still is S and S. So what I did on the other model that we have, I took the bromine and chlorine, exchanged it, broke the bond, and you can see now it's a little bit different. The first carbon is still the same. So we have I dot carbon carbon. Now we have bromine. I dot carbon carbon bromine or bromo. Hydrogen in both cases are still away from us. Sorry, I've moved my models and dropped this one. Now, for this one changed, I changed this one. Remember, if you break the bond, you change it. So now we have chlorine or chloro coming toward us, and bromo is on the paper. So that's what you drew here. Bromo is on the paper, chloro is coming toward us, H is still the same 4. Now you can see, you went to the exercise, it was S, S, and R. Now this one changes, sorry, to S, because remember the priority. Priority now is bromo is first, Br, Cl, and the carbon-carbon. So this is S, not R any longer, it's S. So both of these carbon now are S isomer, the same. Even they look different, but they're still S. Remember priority, nothing to do with the shape and the picture or anything. We look at the priority. They're both S. The first carbon, the other carbon, carbon number 2 is still S and R mirror image, but carbon number 1, remember the Cl, is both the same. So if you have two centers and one of them is the same, the other one is different, we call these diastereomers. Diastereomers. I think I hope spelled it right. Diastereomers. So diastereomers are very different compounds. They have different melting point, different boiling point, physical property different, smell definitely different. So we talk about diastereomers and talk about enantiomers. Enantiomers are a mirror image of each other. Diastereomers are not. They are very different molecules. We're going to do a little bit of practice on that to differentiate and recognize enantiomers and diastereomers. Thank you.